Brownie utilizes the Pytest framework for unit testing. Pytest is a mature, feature-rich test framework. It lets you write small tests with minimal code, scales well for large projects, and is highly extendable. So in part 4 of this series, what we want to do is to dive into testing our Solidity Smart Contract using Brownie tests, which extends Pytest and just using good old Python. So only by properly unit testing our smart contract do we have the confidence that the coin contract would work as it should, and then we can deploy that to a live production blockchain. Right, so first thing we want to do is to go into the test folder. That's that. It should be created the first time we run Brownie in it, and from there, let me just clear my screen. From there, we just want to create a new file, and we want to name it test.coin.py. Okay, so you can name it whatever you want, but try to name something test underscore and then something else here. So you want to start with test underscore, and I'll explain why that is in a second. But for now, just do it the way I said. Test underscore coin.py is probably a good name, and let's start to write some tests. Okay, so the way you write some tests, the way you start writing tests is that you want to start from doing importing. You want to say from Brownie import, and from here you want to import the contracts that you want to test. So in the contracts folder, in build contracts, there is coin, there is simple storage. So what exactly do we want? We want coin, and we know just from experience that no matter what it is that we do, we want to deploy that from accounts, and we know that Brownie will give us it will provide some of this test accounts for us. So I want to just use the accounts so that we can do what we did in the last video, except now in a proper file. Okay, so you can then start to how I like to start my test routines is I like to just set up all the definition and just do a pass. So do it real quick. So what I like to do is I just close the browser, Control B, and I put this to a side, and this will make more sense once you see what I'm doing here. And I'll put this side by side, and the reason I do that is I want to take a look at all of these different things I have in the contract, and I just want to write the test for each one of them. So, and I will just do it real quick, just to just have a skeleton out there first before I put in the details and actually write those tests. So let's maybe start from the state variables here. So there's the minter and there's the balancer. So let's maybe go ahead and do that, and then let's work our way through and look at the other methods in here and address those things step by step. All right, so let's go ahead, say def test, and we say minter. Now on the left, I see this should be a getter, so I should try to get it. If I can do that, then it means the test passed. So we just say getter. Kind of an art than a fixed sign, So just gonna do that pass there, and then we have the balancers gonna do the same things. Test balancers getter, and we're gonna do the same thing here, right? Exactly the same thing. And then we're gonna look at the functions that we have here. So there is the mint. So what we're gonna do is just say test, and we're gonna say min, and we want to say set balance. So what this is, as I write this, I have an idea about what kind of test I want to write already. So in here, I want to say that later on, I should be able to set a balance, and that should work, because this min function, if it's written correctly, this test should pass. So that's what happened. That's kind of what's going on in the brain while you type this out. And then I see that there is also a send here, so probably want to test for that as well. So we're going to say test, and we say send, and once you send, there should be changes to the balance. So I want to say that this one here, I would be able to set balance by calling the mint function, and then I want to be able to set balance by calling the send function, because balance are going to be changed in here. So we're going to do the same thing, and we're going to just call set balance, and I'm going to say pass, right? So then we have what if we want to test that the failure condition also is met, right? If there is not enough balance, that this send function should fail. So I want to actually test for that as well. I want to say that if the fail condition should work as advertised. So I want to say that. And probably the last thing I want to have is this the event. I want to test that the event is there, because later when I create the front end, I can then use the UI to subscribe to the event. If this is successful, I want the UI to change and to add a notification, do all of those things. So I want to just say send event emitted. Okay. If you have any experience with Pytest, writing Python code testings and stuff, you should probably already expect, you should see this being very familiar to you. Now, how many tests do we have? 1, 2, 3, 4. 1 2 3 4 5 6. So if I go ahead now and I save it, okay, it's formatted now. I'm gonna just say Brownie test. And what do I have? It says what? It says collected 5 items. Now we counted 1 2 3 4 5 6. So what's up here? What's happening here? Why do we only have 5? Because here it says collected 5 items, but we actually wrote 6. Now the answer to that lies in the way we name our last function. It should actually begin with a test, okay? And this is also partly why I told you when you start off writing that, I recommend that you just use the same name that I have here, which is test_coin.py. So if you count the tests, you say, well, we wrote 6 tests, how come it only find 5? Well, the reason for that is that Brownie, because it's built on Pytest, Pytest performs a test discovery process to discover how many tests are there, and it used this test discovery process to locate functions that should be included when it runs the whole test routine, the whole test suite. So there are a few rules you need to remember here. The first rule is tests must be stored within the test directory of your project. So it should be stored within the test directory, TESTS, okay? Or it should be stored either this or a subdirectory of tests. So it should be contained either under test, or it should be within a subdirectory under test. So this is okay as well. You can create a new folder and you can call it unit test, and you can put all of this in unit test, and that would be fine. So tests must be stored either under the test directory or a subdirectory thereof. So that's the first thing. And the second thing is that all of the tests, all of the tests here that you see, the file names must begin or must match some sort of pattern. So the file names itself must match this pattern, test_coin.py, or it should be coin_test.py. Okay, so the file name of your test files should be one of these 2 patterns, because then that's how it finds it. That's how the Pytest library is going to find it. Okay, and then the next rule, that's first rule, test folder, TESTS, or a subdirectory of test folder. Second rule, the name of the file, test_coin is fine, coin_test is fine. Okay, or after that too, the third rule you want to follow is that in the test file itself, the methods should be the methods that should be run as tests. They should have this. They should be prefixed with this test_test. Okay, so as long as you have that, then it finds it. There is another way to create tests, and that's using the class, and we can maybe talk about that when we have time later. But for now, I don't want to confuse you. We don't need to worry about that. Okay, so what you need to do is to just fix the send event, and if you save that now and just go ahead now and to continue doing your Brownie tests, you should see that now it's collected 6 items. Okay, so that's good. That's correct. Now, if we start writing our tests, we can start from at the very top. We have this the test minter gather. This is probably very simple to write. Okay, we just have to do what we done in the last video. We have the coin contract, and we just have to do a deploy, and we can say coin.deploy because we already imported coin in there. So this is probably a good time to maybe just bring out this function and just call define deploy, and instead we're just not gonna have this here. We're just gonna have it here like this. And this, we're gonna just have because this is a transaction, we're gonna say from. Some of these are so repetitive that hopefully by now, it's just part of your memory now. Okay, let's maybe just for good measure also print the accounts address. You can say accounts, did not spell that correctly, 0 the address. Okay, and we're gonna just copy that, change this to 1, and finally we're just gonna say return contract, but we don't have contract, so let's go and create that up here. So contract equals equals like this, and here what we need to do is to just call deploy, just like that, and it's gonna run everything in deploy. And then the really fun part is to now do our assert. So this is our assertions. This is what we alluded to in the last video, right? So we can say coin contract because that's what we name it, and we're gonna say check for the minter, see if that is actually the same as this, right? So this is kind of the way you write a unit test, is that you set up some stuff, you arrange for some stuff, and then you act on it, and then you assert and see, hey, this is the minter actually the same as that? And if this is correct, if this passes, then this will return a successful pass, a pass instead of a fail, right? So let's go ahead and maybe just save it right now and just go back down to your terminal, just control backtick and do a Brownie test. So run that again, let's see what happens. Okay, 6 pass. Alright, so far so good, because all of this we just add a pass here, so it's really kind of cheating anyway. But here at least we get what we want, which is to deploy and to get that. You realize though, if we were to look and really inspect the terminal, you realize that, hey, how come the print is not actually happening? Well, we don't actually see any print statements. If you scroll up, let me bring up my terminal a little bit more, so we have more space to look at. Well, we don't actually find that. Do you find it? There's nowhere in here that's printing this accounts 0 address, accounts 1 address. We don't actually see it. So this has to do with Pytest. So by default, print statements just don't appear if you just do a test like that, because Pytest, what happens is Pytest captures the results of standard out. So SD stir out, it actually, like, the results is here, the results that the print statements that you see in here, all of those is captured, and it controls what gets printed and what doesn't get printed, because if it doesn't do this, it's gonna print out a ton of things. There's a ton of like print statements and all of these things. So in order to just have some sort of control, Pytest actually captures that and acts as a sort of, there is an internal process that sort of decide what are things that get printed out. And so in this case here, print doesn't get printed out except if the test fail. So if we try to put a 1 here, so we know that this is gonna fail, because obviously this is, the minter should be 0 because that's where it's deployed from. But if we now add a print statement in here, so it's gonna go ahead and just do a print statement in here. Now this is going to show. So the print statement doesn't show except if the tests fail. So if the tests fail, then the print statement show, because then that's something that is important, right? If the tests fail, it means that, hey, there's something you need to fix. There's something you can do, right? And because of that, the print statement now is situationally useful. So when it's situationally useful, that's when your Pytest is gonna decide to print it out for you. So let me go ahead now and just do Brownie test just to show you what it looks like. Now it says here that this is failed. This has failed, but hey, we have our print statements printing out. The account 0 address, account 1 address, and we have the, now this is going to show. Right? So it tries to be clever about this. Some people like it. Most times it's very reasonable. This is kind of very logical that you want to see it when something fails. But if everything goes smoothly, you don't care. Like, who cares about print and stuff if all your tests pass, right? There is a way to sort of circumvent this behavior. If you like to see print statements all the time as they are being executed, then you can pass the S flag. So you would do something like Brownie. You may be tempted to do something like that. Now this is not the way you do it. Instead, you want to do test, and then you want to put a dash s. So if I run that now, okay, assertion is still wrong because we did not fix that. So let's go fix that, and now it should pass. All of this pass. So now you see that all of this test pass because we just kind of cheated here. But we also see that the print statement is going to come out, and print statement is still going to be evaluated. You see that? So if you really want to see the print statement as you write your task, you can just pass a S flag, a dash S flag. So that's how you do it. Brownie test dash S, and that would sort of make sure that all your print statements get printed out. I'm not sure if that's always a good idea, but it's something that you can have it in your notebook somewhere. Maybe it could be useful. All right. The other idea I want to talk about is this thing called the fixtures. Now fixtures is what is a fixture? A fixture is a function that is applied to one or more test functions. So if we're gonna go down to test balances getter and still do the same thing like this, because most likely we will need to. This is also most likely we will also need to do that. Now it's not to get a lot of like copy paste, and probably the better ways to do that. So this is where fixtures come into play. So fixture is a function that is applied to one or more test functions. Just like this is one test function, second test function, and this is the fixture is called prior to the execution of each test. So we can go ahead here and write a fixture, and then that fixture is going to be used and it's going to be called prior to the execution of each of these tests. And fixtures are really useful into in the setup phase of writing unit tests. It set up some stuff, set up some initial conditions before this test makes sense. So set up some initial conditions like what, like creating a contract, creating the accounts, sending some money here and there to so that the guys that the accounts that are being used in here, they can transact and they can test the actual thing that you want to test in here. So this probably doesn't make a lot of sense until you see something more concrete. So let's go ahead now. Probably won't need the deploy now, so I'm just gonna remove that. Let's try and write this using the fixture. So let's write the pass here. To do that, we're gonna just import our Pytest, right? So if you don't have Pytest installed, you probably should have already when you install Brownie, but if you don't have that, just do a pip install Pytest. But if you have that, go ahead and just import that. So I did that already, and I already have Pytest installed, so I don't have to worry about this step. But if you don't have that, pause the video, install Pytest before you resume. All right, and let's create our first fixture. So let's do a fixture by doing Pytest dot fixture. This is a decorator in Python, and we can give our function a name. We can give this a name, and because this fixture is going to be in charge of spinning up a contract, so just gonna call it define, call this contract. And what this is gonna do is very similar to what we've seen before, so nothing new here. Just gonna say from, and that's just still gonna be the first account, like this, right? So this is gonna be the fixture. Every time we call that, this is gonna be set up, and we want to return this just like that. All right. And now we want to try and rewrite the test minter getter. So instead of trying to rely on that, we just use our fixture. So the way you use fixture is you want to pass the name of this function into, oops, here contract. So Control C, Control V. I did not hit Control just now and pasted V, but Control C, Control V, paste the contract. If you name it something else, you want to pass that something else in here. Okay. Now in this example here, the contract, this function is going to be called prior to whatever that is going to happen in here, prior to running the test minter getter, whatever is going to happen in here. So if we do 1 + 1, then contract has to be run first before the 1 + 1 happen. Okay, so in the test minter getter, we can now just do a quick assert. And what do we assert? We assert that the contract minter, because this is kind of the point of the minter getter, right? Now that is the same as count 0. That's it. So contract, this is a fixture. It's gonna be called prior to this assertion being run, or whatever it's in here. So if you run like 1 + 1, whatever, that's gonna be run. But this fixture have to execute first, all right? And this fixture, what does it do? It returns a deployed contract. A deployed contract instance. So it returned an instance of the coin contract, the smart contract that we created. It returned an instance of that, which is then used in this test, which is why we no longer have to go and define, spin up a contract again here. Okay, so this is how we use fixture, and fixture can also be used. It can also be included by other fixtures. So if you end up having to write a fixture and then there is another fixture that relies on the other fixture, you can sort of, think of it like dependencies. So you can go ahead and actually say something like Pytest, another decorator, and you can now have let's say you want to distribute tokens, because one of this is going to call this fixture, right? So you want to say distribute tokens, coins, and here we can pass this contract into this one, and now it creates a dependency. This fixture can be included as a dependency to other fixtures, and here this is exactly what we did. And here we can distribute coins. Maybe we can give some coins to all the accounts that are in the list. So all of the accounts have some coins, and we can then maybe one of that could be useful in one of this tests. So in that case, if you want to give a bit of coins to all of the accounts in there, you can do something like a for loop. You can say for I in range 10. Why 10? Because that will be 0 all the way to 9. So 0, 1, 2, 3 all the way to 9. So that's all together in 10. And you can do a contract send, and you can say this contract send is back to the implementation that we have here. So what does it take? It takes an address and it takes an amount, right? So we're gonna have accounts. It's a bit crazy because we're giving everyone free coins, but yeah, very generous that way. And then we have a from. So we have the from, and then we want to pass in the account, and let's just say this is gonna be from the main minter. Okay, so let's just scroll a little bit so you can see better. So this is it. So what we see is we just use the contract, a fixture, as a dependency in here, and later on, if this could be useful, we can pass this in and we can do something like that. That will work. Okay. For now though, let's just say this is not really required, but I just want to explain that because it's part of how to use fixture and stuff. All right. And another thing about fixture is you can also apply a scope to the fixture. So what this means is that you can actually set a default behavior for how this fixture is going to be called, or like how often it's going to be called. So the default behavior for a fixture is to execute each time it is required for a test. So each time it's required for a test, it executes again, it executes again. Now by adding the scope parameter, you can change that. So you can add the scope in here, and you can change the behavior of that. So there are a few possible values for scope. You can have the function, class, module, or session. In our case here, let's say if we add module, what is it going to do? Now by applying a module scope to this fixture, attaching the scope to this fixture, what it will do is that the contract is now only going to be deployed once, and the same contract instance, this contract instance, is going to be used for this, everywhere that it's called. So if you call another contract in here, okay, then this is just the same contract instance that is going to be used across these two tests. Okay, so that's a module scope. I'll link to the document where you can read up more about those if you wanna, if there's a time, some extra time you wanna go and look at what other kind of ways you wanna, you wanna work with scope and stuff. You can deal with that. But for now, really, this is all you need to know. This is all good enough. All right, and we have the getter, and then we have the balancers. Let's just go and maybe write the test again. So let's say assert. Now we have a contract. Now this is minter, so this is balancers. Very similar to the one above. Very similar to the one above. Except in balancers, which is here, it asks for it is a mapping, so it needs an address in here. So let's do the first one. Okay, and what do we want to check here? We want to check whether this is equals to 0. So if we were to continue to do a Brownie test, should see that all tests pass. It's getting a little bit boring because tests keep passing, so it's not really fun. So what do we want to do here is to just maybe see how it feels, right? So let's say if we want to say contract balances and we say assert that to be 1. Now this is gonna fail, but we want to see that just to have some sort of just to see how it looks like when it fails. Okay, we have an assertion error. Assertion error where 0, where the balance of this, it says they are not the same. In fact, it gives you a summary info. If you read the short test summary info, it says failed this, and it tells you this is the file, this is the folder, so that's the folder. Then within the folder there is a file, test.py, because there could be multiple files, there could be multiple folder. When I work in production code, when I write tests, I have a folder containing maybe 11 files, 20 files, all of them being a test file. So it tells you very specifically which file to look for. It says test_coin.py is the file you want to look for, and go in there and look specifically for this function, this test function. So we scroll all the way down. Okay, that's that one, test balance getter. And what did it fail? It says it's an assertion error. You're trying to assert 0 to be equals to 1. You're saying that this value evaluate to 0. It's not 1. They're not the same. So to fix that, just change it back to 0. Go back down. Brownie test. Whoops. Brownie test. Okay, now it passed. Okay, so up to this point, if this looks familiar enough to you, and if you have some experience in Python, I feel like you should have no problem continuing with the rest of the test code. I feel like you should have, this should be okay. It shouldn't be too much of a challenge. So if you want to, feel free to pause the video, try and flesh out the rest of the test and see how much do you get before you resume. I'm gonna give you like 5 minutes, but then you can resume the video anytime you're ready. Okay, did you write the test already? I hope you did, but let's go ahead now and just do the rest of the test here, right? So let's do an assert here as well, and we say test mint set balance. So set balance. So what this function is actually trying to test is that if we use the mint, we should alter the balance of the receiver by some amount. We want to see if that's true. So how do we test whether that's true? How do we check that this is gonna give us what we want? So let's go ahead and think about this. We first need to set up a mint, and then once we set up the mint, we want to be able to check for the balance after we done the mint. So we first run the mint, check for the balance, and see whether the balance confirm with our with what we expect in here. So let's go ahead and do a mint first. So we need to again take the contract, put it in here to run the fixture. So then we have the contract, and I'm gonna say contract, and what are we gonna do in here? We're gonna say mint. Okay, so just to give you more space to work with. So contract.min, you want to min. Let's create two mint function call. So the first one, we're just gonna give it to our own account, just the first account, not account, and we're gonna give it 10,000, similar to what we did in the last video. If you haven't done the last video, and we're gonna call this from 0 because anything else would fail. It has to be from 0, okay? Because that's gonna pass the check here. That's gonna pass the check here in the mint, the require, right? And then we're just gonna sort of duplicate this line of code, and we're gonna change this 0 to 1, and we don't need to give them 10,000. We just have to give it 5,000 or something, right? And anything. And so once we've done this min, we can do an assertion. We're gonna first assert that the first balance, the balance belonging to the first account is exactly 10,000. So let's do that. So contract and balances, and in balances, that's a getter. So we need accounts 0, and we want to check that that's gonna be 10,000. Then we're gonna do the second one. We're gonna put 5,000, but this is gonna be 1. Okay, so that's how you do it. If you want to test it out, you can go ahead and do that, but you're just gonna move on. Test send set balance. Now that's gonna try and test this. So the another way we can sort of alter the balance of our accounts is to not mint but send, right? So let's maybe just copy this, put it in here. So what I'm doing is that I'm just gonna do the same process, mint it, and then I'm gonna say contract.send, and I want to send from the first guy to the second guy, right? So I want to say send it to my collaborator. So accounts send there. How much do you want to send? Let's say 1,000. You can obviously play with your own value, but I'm just gonna keep the math simple for myself, and I'm gonna just say from, and I'm gonna give it from my account. So that's that. And then what we want to test, for the contract balances. So very similar to what you have above. And in fact, what is a good idea is to check for both. So you can have 0, and you can say 1. So the first guy, he has minted 10,000, but he gave away 1,000. So how much do we have left? 9,000. Okay. What about the second guy? He have 0, and then he was given 1,000. So what do we have? 1,000. That's it. Test send balance. So that's kind of it. Fail revert, we haven't really done that yet, but let's maybe, before we even go there, let's just run the Brownie test, make sure all of this works as expected. Oops. Function object has no, so when it says test send set balance, and it says contract.min, because we did not pass in the contract, did we? So save that, Brownie test, bam, done. Alright, so now on to sort of the fill, trying to test that the send has filled. So this is, we're gonna use a concept called Brownie raises, and we're gonna see this later. So when we, let's just write this test out first, and then we can talk about that, right? So let's do contract, and what we're gonna do is we're gonna say, you can, if you import Brownie at the top, if you do an import Brownie at the top, then you will do something like brownie.revert, reverts. You will do something like this. So you say with Brownie reverts. But because we did not do that, instead we're gonna just go up here and we're just gonna add reverts. So we don't have to import the whole thing, we just have to bring down reverts. And now we just have to go in here and we're gonna say with reverts. So this is another thing that Brownie provides. It's very similar to how Pytest has the Pytest exception. So in here we just say with reverts. We want this to revert because if this works, it means that this logic check is this gate, this checking that the require statement, that is working, right? So if this doesn't pass, it means that, hey, this is not really working, and that is going to be an issue because now people can send money that they don't have, and you don't want that to happen. So what we're going to do is to just create a situation where this is completely bonkers, should not work. Let's do something like contract, which is going to be from here, and we're going to say send, and we're going to say send from what? Send let's say send to the first account, send 500. We don't have 500 because we haven't even started the minting process yet. Okay, or 1,000, up to you, right? Up any figure. And let's put from accounts 0. So this is gonna hopefully throw a revert, meaning it should fail. If this fail, then this condition pass, because then it means that the require statement is doing what we want it to do. Okay. Let's maybe, just to be more robust, I guess, let's maybe also create a mint now and send something more than what we minted. So let's go ahead and say contract, and now we do a mint, and we say mint, give it to ourselves, give it 10,000. Same thing here. Oops. Now we mint that, but we still want to revert because we want to now send more than what we have. Just to be more fail-proof, just to be more bulletproof, right? More airtight about our situation. Here we want to say send now, because we maybe we suspect that there is some part of the logic where if you have nothing at all, it would fail. But if you have something and the something is still smaller, it wouldn't fail. So that would be a problem as well. So we want to just be robust. Therefore, I'm gonna just check for, I'm gonna just, you know, have one check for the condition where I have 0, and the other one where I have some amount, but the some amount is still not greater than what I'm trying to send. Okay, so hopefully all of this makes sense. And I'm gonna say accounts. I'm gonna send it to the first guy, okay, our collaborator. But I'm gonna send 10,500. I clearly don't have that amount. I only minted 10,000. I'm trying to send 10,500. Okay, so let's see what happens there. If everything works out, we should see that this tool will successfully revert, and then this test would pass. Okay, so let's go ahead and do that. Brownie test. Fingers crossed. It works. Another thing you can do with reverts is that you can actually have a optional string as an argument, kind of put in your own string as an argument. But if you put in a string as an argument, the error string returned by the transaction must match it in order for the test to pass, right? So if you pass in a string like this one, what do we say in here anyway? We say not enough balance. Sure, let's copy that. Let's pass this in here. So if you pass in a string, this is optional, but if you pass in a string, now the error string that is returned by our transaction, they must match it. Okay, remember how in the last video we talked about the error message, the revert message, revert underscore msg? That is the revert message. That has to match this. If not, even if you revert, it still doesn't pass. Okay, so let's go and up the challenge a little bit. Run Brownie test. Great, everything still works. So we still have all of this working, and sort of the last test here. Again, I don't know if you want to pause the video and try that out. If you did not try any of the tests, maybe this is a good time to write your test here. And you can take a minute, and then when you're happy with the work you've done, resume the video. Okay. Great. Now let's start. Let's say contract.min, and we want to first min some amount so that we can use that amount and send to some other amount. If we don't min, we don't have enough to send. If we cannot send, we cannot emit that. So we need to start from mint. So this is really more about thinking than, you know, writing code. The codes are so repetitive, they're so similar anyway, right? 10,000, and want to do the same thing. Want to say from, what do we have? We take the first account. Now we have enough coins to actually make a transfer. So this is where we make the transaction. So we want to say contract.send, and want to send to the second guy, our collaborator. So let's do accounts 1, being very generous today. We have 10,000. How much do we want to give away? 2,000 maybe. Okay. Pick an amount. Up to you. As long as your amount makes sense, that's fine. So once we have transaction, now we can do a couple of things. There's one way to check for that is to just see whether this key even whether even exists in the events itself. So I can say, let me make sure the name is there. Correct. So go all the way up there. Okay, it's called send. So I want to make sure that send is in tx.events. So that's the first assertion. I can also do a count. That's also okay. So I can also do a assert and what tx.events.count. Again, pass in the same name. So this is called send. So let's do send, and that should be equals to 1. So you can also do that. So let's save that. Let's go back down here. Brownie test. Let's run. Hopefully everything still works out. Nope. It says that the contract mean, because we again forgot about the contract. So let's do that. Save that. It's getting late. So Brownie test. All right. Okay, cool. Everything works. Okay, so far so good. This is all you need to do. But I'll just give you a few more tips and tricks before we go. Now, if you just write this test and you don't want to rerun everything because there's a ton of tests. Let's say you write in a real world project, I usually deal with tests going up to like 60 tests, 50 tests, 80 tests, a lot of tests. So if I just added a new test here, I don't always want to run the whole. I just maybe only want to test this new thing that I just added. So the way you do that is you can say something like Brownie. You can say something like Brownie, and you say test, and you say dash dash update. Now what dash dash update is doing is when you add an update flag, it say that after the task suite has been run once, you can use the update flag to only repeat tasks where changes have occurred. So if we do a test like that, it's going to run everything now. But if we change this send to, for example, and if we do the update again, it's only going to see what is it that has been changed, and it's only going to test that. And that's how you use the update flag. Okay, and the other thing you can do is you can test for specific tests. So for example, this test, I want to only test for this test. So I don't want to run all of that. I only want to run that test specifically. So I can do a Brownie test, and I can put a dash K flag, and I can pass in the name of that. So in this case here, the name of this specific test. So instead of it going around and trying to run the whole thing, it's just gonna run this one test instead of doing the whole thing, right? So just do that. So it says 5 deselected, so it deselect all the other tests and it only run this one test, and that one test turns out it passed. Okay, and so you don't have all the 6 dots anymore, you only have 1 dot. So if you compare that, each dot means a success, means a successfully pass. If you see a big F here, capital F, it means it failed. So here we have 6 dots, but here we only have 1 dot because it's only running that one. So if you only want to test only this one function, you can just use the K flag, the dash K flag. If not, you can just do the update. You say just update, and you only repeat tests where changes have occurred. Another thing you can do is to just do a Brownie test. You can go into interactive mode, just like that, and it will run all the tests, but it will also put you into interactive mode if any of the allows you to debug your project if anything fails. Okay, and that is kind of cool. But what is also useful is that later on, when you try to write all these smart contracts and stuff, you want to be aware of what kind of gas usage do you incur in your contract. And so you can generate a gas profile report from Brownie itself. You can say Brownie, and you can say test, and you can say dash dash gas, just like that. And so it's going to run all of that, and it's going to give you a gas profile report. So it's going to tell you that, hey, in the coin contract, your constructor is going to take quite a bit of gas. Okay, these are all in the units of Wei, W-E-I. Okay, so these are all the units of Wei. Remember that 1 ether is 10 to the power of 18 Wei. Okay, so this is not even 1 ether, right? But it's gonna take some. It's 244,000. It's moderate. Okay, it's moderate. And it try to give you an average by looking at the times it runs this and what is the low, what is the high, and it try and find an average, and it tells you that this is the estimated gas that you're gonna use. All right. Then the cheapest function is the send function. Send function is actually cheaper than even the min function, but this is not very conclusive because you can see that the average here, if you look at the confirm and you look at the low or the high, there is still a pretty big variance in there, right? So because of the big variance. And the reason why there is a big variance is because when you send, a lot of things could happen. You could be sending to accounts and doing all kind of checks in there. You could be sending to multiple accounts and stuff. So there could be a bit of variance in here. And you compare that to Mint. But anyway, you can see this coin profile, the gas profile report from here. You can also try to get a coverage. So to get a coverage, if you're actually a Python developer and you use Pytest and unit test and coverage and any of this libraries, this is all very familiar stuff to you. But if you don't, let me just run that for you. You say dash dash coverage, and it would produce a report, a coverage report, but it's not printing out anything in here. And the reason it's not printing out anything in there is because this is a known issue related to this issue on GitHub. Let me copy that. So this is a known issue. If you trace it to GitHub, you can see that there are people who have found this, and this relates to the use of the immutable keyword. So when you don't get your coverage report, one thing you can do is to go back to your contract. For now, I mean, this is all temporary issues that they're gonna sort out. I mean, if you're watching this video 6 months from now, 5 months from now, there is a good chance this has been sorted out and you don't have to do anything on your part. All right. But for now, there is an issue relating to this, and people are aware of that. They're trying to fix it. So what we're gonna do instead is to go back to the coin contract and notice that there is the immutable keyword in here. Well, we're just gonna have to remove that. You say that, well, is that gonna be a little bit, you're compromising on that, right? But I mean, you can swap it with constants and then take away the constructor and just assign a value and just put a value like that. You can also do this. But because I know that it's only appearing in constructor, and we can even test for that anyway, we can write test to test for that anyway. We can try and test and see if anyone can play around with Minter and try and set a value, and if they can, then one of our tests will fail. So I feel relatively confident. I feel kind of confident that there will be no issue. So I'm just gonna take away that one. And while I'm in here, I'm also gonna take away the if here. So I'm gonna take away all of this because it's not gonna be useful. The reason I'm taking away this is because the require already do exactly what this is doing. There is no extra value from doing that. So might as well remove that. And the other reason is if I don't remove that, I need to test for this as well. And it's kind of hard to test for this because if the condition is satisfied, they will already be blocked here anyway because this happens before it. So if there is something that if I could test this, I need to first get past this. But how do you get past this without and still fail this? It's kind of hard to reason about. And because I can't test this, or I don't have good ideas to test it right now, I'm just gonna comment that out, and this will do exactly what I wanted to do anyway. So I'm just gonna make the two changes. So first of all, remove the immutable keyword, and then remove the additional if statement that is unnecessary, completely unnecessary. And I'm gonna just do a Brownie compile because I make changes to my contract. Every time you make changes, you want to do a Brownie compile. So let's do that. Okay, now we remove that. So we take the chance to remove the extra if check, and we also just remove that immutable statement up there, the immutable keyword up there. So now it's time to go back in here and try our Brownie compile again, Brownie test again with coverage. Now we see some sort of coverage here. So there's the coin, 87.5%. This is an average of these two. It says that for Sand, you have 100% coverage. That's fantastic. But for Mint, you only have 75% coverage. So, and you can also, there is a generated JSON file for the full report. You can click on, click on that, and it would open that up. I'm not going to care about that. So because I don't care for that, I'm just going to close it. I just want to maybe bring this up to 100%, and then this will give us full coverage of the coin. You want the coverage to be as high as possible, because coverage gives you a good sense of how much of the contract, all these features, all these things that you've written, how much of that have you properly addressed in the test scripts. So I want you to maybe pause the video and now think a little bit about that. How do you? There is a coin mint, so clearly we don't need to do anything more on the Sand. Because Sand already have 100%, but the mint is where we can maybe improve on. So what can we do here? So Sand is covered. We need to improve on mint. There is something else that we haven't covered. So what do we do here? Pause the video, think about it. Have any idea? Alright, so it turns out one other thing we can test for is this require statement, and make sure that it should fill if anyone try to play around with that. So we can go ahead and say test that mean will fill or has filled, whatever, and we're gonna give it contract. And now we do a mint, but this time we want this mint to actually fill. So we want this mint to actually fill. So how do we do that? We use what we learned before about reverts. So with reverts, and we say min, want to pass in. Let's try to give we can give it to 0 as well. Let's give it 10,000. But now we want this to fill. And the way for this mint to fill is to have this from somebody who is not the minter. So anyone who is not a minter. So this could be from account 1, from account 5, from account any account. So if you try accounts and you put in accounts 5, accounts 4, accounts 1, any of this, it will fill. Hopefully, right? And let's do this. And so this is a good time where you can just do a Brownie test, and you can just do a quick update, and there we just update, and you would just run the test, and okay, all of that passed. But now you can also go ahead and just do a coverage, and yay, we have 100% for mean and 100% for send, and so we have 100% coverage, and that's all we have for our test. So this is testing the coin. If you really want a bit more challenge, go ahead. There is another contract in there. Try and create a file. Do the same test, but this time do it on the other contract. This should be relatively easy because it's just a simple storage. But congratulations, you've learned how to write tests for your contracts, for your smart contracts. This will make you so much better as a smart contract developer. And in the next video, we're gonna go ahead now and implement something even more full-fledged than Coin. So Coin still, in the scheme of things, is still a relatively simple smart contract, but we can maybe add more bells and whistles to it. Or we can just go ahead and start a new project, create a new smart contract, and with a lot more, a much more comprehensive example of how a full-fledged smart contract is going to look like. Oh, and before you go, I also want to remind you that all of the code here is going to be on my GitHub. So go into the GitHub. There is a link there right there in the description. You can find all of this test coin. If you fail to follow any of this, you can slow it down, pause the video, go to the GitHub, look at the reference code itself, and try to implement it. That's the best way to learn. That's all I have to say. See you in the next video.